So yeah, to continue again on the next program, what we'll be doing is we will utilize the matrices only now, but we will do some another form of matrices. Like let's say as part of my input, I have a matrix and I want to transpose it. So transpose is I'm aware like you might be aware of like what the transpose of matrix is. Like let's say we have a matrix like 1, 2, and then 3, comma 4. If you want to transpose this matrix, how the after transposition of matrix, what happens is 1 remains there because it's a diagonal element. Then instead of 2, we get is 3, and instead of 3 here, we'll get is 2, and 4 becomes same because it's a diagonal element. So this is how the transposition works. Now let's say we have a 3 cross 3 matrix 1, 2, 3, 4, 5, 6, 7, 8, and 9. So how do we transpose this? So my first row here is 1, 2, 3. So it comes as column. So 1, then 2, and then 3. So this is a transposition of my first row. Now what happens is 4, 5, 6. This is my second row. So how do I transpose this? My second row 4, 5, 6 would be transposed as 4, then 5, and 6. And then the third row, which is 7, 8, 9, becomes is 7, 8, and 9. So this way, any given matrix is transposed. So we need to write a program to transpose a matrix. Now, transposition of matrix, as we saw, it's nothing but like shuffling of your rows to columns and work accordingly. Now, the internal logic here, if you see, and the position of every matrix, if you know, if we take every position, right, the first element's position is 0, comma 0. Then the second element's position is 0, comma 1. Third position's element's position is 0, comma 2. Same way for my second row. These are my positions. Now this position 0, comma 0 is nothing but I, comma j position. So I is pointing to 0 and j is pointing to 0. Then 1, comma 1, 1, comma 2. Then 2, comma 0, 1, comma 2, and then 2, comma 2. So these are nothing but the positions in a matrix. So let's say we have a result matrix, which is 3 cross 3, and these are the internal positions. And position of my first element is 0, comma 0. Second element is 0, comma 1. Third element is 0, comma 2. Fourth element is 1, comma 1, 1, comma 0, and so on. And if you transpose this corresponding matrix, what becomes the logic is your I, comma j pair, which is any of this position, becomes j, comma I. So this is the transposition formula for any matrix, that if you want to transpose a given matrix position, the formula you need to apply is your I, comma jth element, which is, let's say your I, comma j is this element, right? So what is my I and j? I is 0 and j is 0. This is going to be shuffled to j, comma I. So your final output is going to be 0, comma 0 only, because your first position was 0, comma 0. And since they both are same, j, comma I is becoming 0. If we move to second element, which is 0, comma 1. So 0, comma 1. I is 0 and j is 1. Now if we transpose this, what is the formula giving us? It should be j, comma I. So what is my j? J is nothing but 1 and I is 0. So your element at 0, comma 1 position is going to be swapped with 1, comma 0. So where is my 0, comma 1? 0, comma 1 is here and 1, comma 0 is here. So these two elements are going to be swapped. Now if you look over here, now 2, comma 4 are swapped to 4, comma 2. So this way these elements are swapped. Then the third one is 0, comma 2. 0, comma 2 becomes 2, comma 0. So that means this 0, comma 2 is being swapped with this element. If I see here 3 and 7 is being swapped with 7 and 3. So this is the ideal formula for transposing a matrix. Now look at this formula. Now it is very easy to implement. Now let's create a matrix. Like let's say matrix is the same matrix which we'll copy, but here we need to put it inside a list, comma, comma, and then internal element should be separated by comma because it's a list. So this becomes our input matrix, and then my output should also be in the same. So I'll just replace its name as output, and by default I'll have is just zeros there. And then I will remove this. So this creates our input matrix and output structure. Now, as usual, we'll define the function to transpose matrix. And here, as part of input, I will take is the matrix and the result. And the logic here would be, again, I would be using the two for loops, which we understood in the last program. So the first for loop was nothing but going over the every row of the matrix. So for I in range, length of matrix. So this is going to loop over row, which is nothing but taking this row like one row at a time. So first row, second row, and third row. And then second for loop is going to loop over your column. So for j in range, length of matrix of 0. Now why do we took 0 is to refer to the length of my first row itself, which is length of column. So this is to loop over column. Now what is the range here going to be? Range here is going to be 0 to 1 only because it is 0, 1, 2. So length is 3, so it is going to be 0 to 2. Same way for column, it is going to be from 0 to 2 because length of my matrix 1, if you see length is 3, but range is going to go from 0 to 2. And then the for loop. Now this for loop, if I print again, we can see the positions which we are getting in the for loop. Now let's call this function transfer matrix, matrix, and result. Run this. Matrix 1 equal to this, this. This thing also goes above. Then transpose of matrix 1 and output. So this is nothing but output. Okay. So if I run it, I should see the positions for every element. So 0, comma 1, then sorry, 0, comma 0 is the first position. Then we have is 0, comma 1, then 0, comma 2. So these three positions are nothing but my row number 1 positions. These three positions are my row number 3 positions. 1, comma 0, 1, comma 1, 1, comma 2. And then these are my row number 3 positions. Now every first column which you are seeing is nothing but our I, and every second column which we are seeing is nothing but j. So as per the logic, like the formula for transpose, your ij becomes ji. So how we will write is result of I and j should be equal to matrix of ji. So this way, for every element here, it is going to be switched to j comma I. So every j comma I position is going to be swapped. And then finally, we'll get the output in result. So if I print result now, let's verify if it is transposing or not. So 147, which is this 147, becomes your row, then 258. So let's do it in a structured way as we did for last. So for row and result, print row. So this is the transpose of your matrix. So transposition is 147. Now this is becoming a little bit hard to validate here. What we can do is we can just give a message here, print transpose of matrix, and then before that what we can say is, before even doing this looping, what we can say is print original matrix, and then I can just do a print row in my matrix. I will do is print row. So why I did this first thing is this will help me show what is my source data, which is this matrix. And then once I'll process this code, which will transpose the matrix, and the final result will be printed here. So that here in my output, I'll see two things. One is my source matrix, which is this, and the final output. So based on looking both of the input and output, we can validate if the transposition worked or not. So this was my original matrix. This is the transpose of matrix. So every ijth element, like position at element at every I comma jth position is been switched to j comma I position. So 2 and 4 are swapped, then 3 and 7 are swapped, then 6 and 8 are swapped, and the diagonal elements remain same. So this is how the transposition works. So this is also a little bit similar to our previous program because it was more of a matrix program. And the reason why we did is this is like two-dimensional program where we have to utilize something in the sort of two-dimensional. I hope now this is a little bit easy to understand because of our previous program. It should be a little bit easy to understand now. Now, as part of your homework, what you can do is, now we have done is two type of programs. One was transposition and the previous one was addition. Or the program you can do is you can take two metrics as an input, matrix 1 and matrix 2, and you'll have to multiply those two metrics and store the output in a result format like this. So basically you need to do is write a program to multiply two metrics and store it in the output. So that matrix program is also going to be similar in nature. The only change would be in this portion, like where the actual logic comes, how you'll perform the multiplication. And that logic is almost similar to the first program where we did is the addition of two metrics. The only formula change was there. So this completes our two-dimensional programs also. Now what we'll do is we'll do few more programs on dictionaries because dictionaries are also being widely used. And if you know dictionary and list programs, then we can do it for set and tuple also because there are very few programs which are not even required to do in set and tuple, because all the programs can be handled in list as well as dictionaries itself. So whatever programs you've done in list and dictionaries and previously used all the operators, that can be done similarly in tuples and set also. So for now, what we can do is we can do a program where we have a dictionary, and basically we want to find is, let's say we need to write a program to add all the values of a dictionary. Now, what does this exactly mean? All the values of a dictionary. Let's say I have a dictionary like this, which contains keys and values. So let's say I have a variable called as A, or let's say I have car one and its price is, let's say, 100. Then I have another car two and its price is 200. And then I have car three and its price is 300. So as part of my output, what I want is I need to add all the values of dictionary. That means 100 plus 200 plus 300. The output comes out to be 600. So this should be my final output. So what does this program tells us? We have an input which contains a dictionary, and the dictionary contains key values, and you want to do is add all the values inside your dictionary and print the output. Now the reason why we are taking this program is, here we learn is how do we loop over a dictionary again, and how do we access the values when we are looping also. So two operations at a time. So now to do this, we'll create the structure of our program first. So what we need is define a function which is called as add values, and input here would be a dictionary. Then my dictionary comes here, and then I will call the program function. Let's print this to see if the all other things are working fine. Yeah. So this is my dictionary. I'm calling this function and these are my values. Now, how do we add all the values is? It's pretty much straightforward is we have to use is nothing but a for loop. So for element in dictionary sum equal to sum plus dictionary of element. Or if element is getting confusing, then we can write is I. So what we are saying is for I in dictionary, that means for every key in my dictionary, I will do addition, and to access the corresponding value, we'll do is dictionary of I. So this syntax is going to help us access the value, and this is accessing over a key. And this sum is nothing but a variable which we need to declare by default as 0. So sum equal to sum plus dictionary of I. Now this can be again shortened into plus equal to also. But just for a clear understanding, we can write in a formula way. And if I run this, let's see if it is doing the addition of elements or not. So you see 600. So this is one of the way of adding all the values. Now, why this is one of the ways? Approach one. Here, what we did was used key in for loop and then used dictionary of key to access the value, right? Because here what we are doing is this I is nothing but these keys. Because if I print these keys, right, print I, you'll see we are seeing is nothing but all the keys. So these are my three keys. And for every key, I'm accessing the corresponding value. So corresponding value was accessed using this dictionary of key format. So if you put a dictionary of key here, we are going to get is the corresponding value out of it, which is 100, 200, and 300. So this is one of the approach where using key in the for loop and then using dictionary of key to access the value. Now what can be the other way? The other way can be we can directly go over only the values and not even going over the dictionary. So let's say for value, v for value in dictionary dot values. So this is the second approach where we are instead of going over the keys and then accessing value, we'll directly go over the value like 100, 200, and 300 to access the corresponding value. If you want to confirm if the corresponding value is correctly pulled or not, what we can say is print v. Now for now, time being, I'll just come in this code. If I run this, we'll see we are going through each and every value instead of keys in this second loop. So this is a second approach. Now, since we are going to every value, what we need is again this sum, and here the formula would be sum equal to sum plus v, and at the end of the for loop, what we need to do is print sum. So this way we are going to get is a 600, which is the output. So this is the second approach of adding values in a dictionary. Now, what was the second approach? We used dictionary dot values to access the corresponding values to loop directly over the values. Now, using this dictionary dot values, how we were able to get is we were able to get all the values of the dictionary, and then sum is equal to sum plus v, which was helping us to print all the values internally. Now there is another short way of doing this is if we have this dictionary of values, right? Now if I just print this dictionary of values, you will see it is nothing but a list. What happened? Dictionary dot value. So this dictionary dot values, if I just print, you will see all the values like 10, 20, like 100, 200, 300 inside a list. Now using Python's internal inbuilt function called as sum, if I just apply sum over this dictionary of values, and if I run it, I will add all the elements here. Now what is wrong here? Let's remove the sum, run this. Okay. Now, since we are getting an error, now how do we debug that error is we can utilize the same print statement, but apply a type function there. Now using this type, we can understand what kind of dictionary is this. We should see it is a list, but it is telling dictionary of values. So the way here can be done is we can apply list over this function which can cast your dictionary.values to a list value. Now, if I run this, now this dictionary underscore value should be converted to list. Now, since we have a list, now we can directly apply a sum function instead of type. Now, again, this sum int object is not callable, which happens on line 24. Okay. It looks like mostly because of Python's version, it's not adding. But ideally, whenever we have a list like this, and if you apply that sum function over that list, it ideally adds all the element inside that list. So the reason of showing this was nothing but there is one more approach of adding the elements. So approach number 3 was like Pythonic way to add all the or like way to perform sum over the list over the values using inbuilt functions. So now using this inbuilt function, we can add it. Now, since this is list and dictionary of values, which was again a type. Okay, now why it was not adding, maybe int object is not callable. Now, since we don't even have int object, why it is saying, if I remove this print, will it print? No. So looks like some Python version issue, but ideally it prints. So for time being, what we can say is this was just like an optional way. But ideally, in order to add any two like add all the values inside a dictionary, we usually perform is these two ways. Now there is one more additional way other than this way is we can just ignore this. The other way was we can utilize key comma value in dictionary dot items. So this way we get access to key and value inside my dictionary. If I print this, I'm getting access to both at a time. Here I got access to only the values, but here I'm getting access to both the values. Now the print k comma v is going to give me key and value. And then the formula can be same again. I can just print this formula. And if I do just print sum, this is again going to add all the values, which is 600. So this was the approach 3, for example, where we used dictionary dot items to loop over keys and values in dictionary, and then used values to perform addition. So this is the approach number 3 where we can add. So the reason of showing all these 3 or like more approaches is like the way Python is providing is the functionalities. We want to be aware like which approach we want to use. Like, and there is no harm or like any benefit or like a disadvantage in any of the approaches. The only thing is you should be aware like which approach or like there are multiple ways provided by Python and we can use any of these approaches to work on any kind of dictionary. or else there is no other like harm in using like this approach one is advantageous over approach two and three. There is nothing like that. All three are same, and we can use any one of that based on our understanding. How do you want to use it? So this completes our addition of all the elements inside my program, like inside my dictionary, using these three approaches. And the things which we learned over here is nothing but using inbuilt functions like dictionary.values to loop over the values inside my dictionary, then dictionary.items to loop over keys and values inside my dictionary, and then using the keys also. Now there is one more quick way over here is this by default is nothing but dictionary.keys, which is by default, and if you remove it then also it's going to loop over dictionary's key. So by default, whenever we write a for loop over just dictionary's name, it is going to loop over dictionary.keys, which is nothing but your same dictionary.values. And here we are looping over the keys. That is the only difference. And to access the corresponding value, this is the corresponding syntax. Dictionary of key is going to help us access the value. So that completes most of our programs in Python. And is there any doubt in this program or any other program which you have in mind which you want me to do? We can do that in our upcoming session.
No, sir, no doubts.
Okay, okay. So I think so then we can wrap up for today and then we'll continue in our next session based on like how you want, like we can continue with SQL or we can clear on doubts as you discuss with ma'am. We can look accordingly in the next program, like next session. Okay, so
Yes.
that's all for today.
Okay. Okay. Thank you so much, sir.
Thank you, everyone. Thanks.